Hi everybody, welcome to our second lesson today, and we are looking now at volume. We're going to calculate the volume of a geometric solid, and in this lesson we're going to just look at a particular type of shape, which is a box, or another way to say that is a rectangular prism. Okay, so to review volume, we just looked at area, and the units of area are always in square units, so squared centimeters, squared meters, square feet. Volume is a little bit different than area, and the units are always cubed. So anytime we're reporting an answer for volume, we're going to see that we have cubed units, so cubed centimeters, okay? And cubed is simply saying that you have that unit, centimeters times centimeters times centimeters again. Okay, so we're going to have three different dimensions here that we're going to be multiplying together that are going to give us those cubic units. The formula for volume depends on what type of shape you're looking at. Your data pages provide you with the volumes of a whole bunch of different geometric solids. We're going to go to page 3 right now of your data booklet. If you don't have it open, pause this right now and open it up. And you're looking at page 3, which has different formulas for volume. So here's our data booklet right here. And you'll notice that on the page before it, page 2, the geometric figures that you had down here were all in 2 dimensions, rectangles, triangles, and circles. And we were only given the formula for area. Okay, we weren't given the formula for volume anywhere on this page. So we're going to go to the next page, which is page 3. And here I see that I'm given a surface area formula, which we're not going to use right now. We'll get to it later. And here's volume. All of this column is showing formulas for volume. A rectangular prism is what we're going to deal with today. Okay, we'll deal with other types of shapes a little bit later on in this chapter. And so if I go down my screen a little bit here, just one moment. Okay, there's a box, and I use this word box just to kind of keep things simple, but the difference between a rectangle and a rectangular prism is a rectangle, okay, just has 2 dimensions, length and width. Okay, a prism is something that has height as well. So these are all 3-dimensional shapes, and this is just the mathematical term for a box, like a rectangular box. It's called a rectangular prism, and the height is from the bottom to the top of that box. The length is along the base, and the width is also referring to the base. So one thing I want to mention here is that when you're looking at volume, the base of this prism is right here. It's again, just like a triangle, it's the part that it sits on. So if you have a box on the ground, the base of that box, okay, would be the part of the box, the face that is sitting directly on the ground. This is called your base. Okay, and then the height of that box is running from the base to the top of the box. And you have another identical face on the top of the box, identical to the bottom. What's really important that we recognize here is that when we have our formula over here, okay, volume is equal to the area of the base times the height. Don't let that confuse you. The base here is a rectangle. If I looked at the face that this box sits on, it's a rectangle down at the bottom. And the area of a rectangle is simply the length times the width. Okay, so another way we can rewrite volume, and I'm going to encourage you to write this right now on your data sheet. Volume is equal to the length times the width times the height. And that is a little bit easier to work with than the area of the base times the height. Okay, you should always have 3 dimensions, length, width, and height, and we're going to multiply them together. That's why we get cubic units, because both the length, the width, and the height all have units associated with them. So if they're in centimeters, I'm going to have centimeters times centimeters times centimeters. Gives me cubic centimeters is my answer. The volume of any object is referring to how much space it takes up. And so the reason why we use this formula, length times width times height, is that if we wanted to know how much space, so imagine that I was filling this box with I don't know, Smarties. And I want to know how much space are those Smarties going to take up. It's going to be equal to the base of that box multiplied by the height, so all the way up to the top. Okay, that's going to tell me how much space I have in that box. I have to take all three of those dimensions into account. Let's go back to our notes and do some of these questions. Okay, so formula for volume on our data sheet. Okay, if we're talking about a rectangular prism, and that's all we're going to look at today. Okay, the formula is this: V is equal to the area of the base times the height, and we're going to rewrite that as the length times the width times the height, because the length times the width is really just the area of the base. Okay, it's just the area of the rectangle on the bottom, right? The width times the length, that gives me area. Okay, and then finally we're going to times by the height. Good. Let's do an example. Calculate the volume of a rectangular prism that has these dimensions. Okay, 1 foot by, we can also write by as times, okay, 3 feet times 5 feet. Oops. Okay. It doesn't actually matter here which one you identify as length, width, or height, because you already have all three dimensions. One of them is going to be width, one of them is length, and one of them is height. We could, for the purposes of just trying to draw a picture right now, we could call this one length, okay, call this one width, and call this one height, okay, and then I could, if I wanted to draw myself a little picture, I could. Okay, it's got a length of 1 foot, so this is kind of a box that is not that long, so 1 foot. Okay, the width is 3 feet, so this is kind of sort of a long box, so the base of the box would look something like this. Okay, 3 feet. In fact, sorry, let me just draw that a little bit differently for you. Apologize. It would look something like this. Here, I'll do it this way. So it's 1 foot. Turn it a little bit easier to draw it. Okay, let's say make the width about 3 times longer. Okay, something like this. And then it has a height of 5 feet. So it's actually coming up here. Okay, the height is about 5 feet. Okay, and just kind of connect all of those there. Okay, so there would be my box on the top, would look something like this. Okay. You don't have to draw this picture. I'm not doing a very good job anyways. Okay. Something like that. There's my box. Okay. So again, we're just using this formula. V is equal to those three dimension times together. So length times width times height. So we're really just going to do that. It's 1 foot, okay, multiplied by 3 feet, multiplied by 5 feet, and 1 times 3 is 3, 3 times 5 is 15, and your units are feet. How many feet did you multiply together? 1, 2, 3. You multiply feet by itself 3 times, that's feet cubed. So our answer is 15 cubic feet, okay, for this question. This is essentially all we need to do for any volume of a rectangular prism, okay. In your worksheet, you're going to do a couple of different examples here. Maybe I'll just do one more for you just now, just to give you one more thing to look at. So let's do just one more example of volume, okay, of a rectangular prism or of a box. Okay, we should be careful that we recognize that a box is a rectangular prism. And let me draw you a box. Okay, so let's say it looks something like this. Okay, and we could draw the base on the bottom just to show the base there. Okay, so there's a box, and let's give it a length of 6 6 meters. Okay, and this dimension here, which would be our width, that's going to be, let's say it's 2 meters. Okay, and let's say our height looks to be also about 2 meters here. Okay, and so the volume of this, I recognize that it's a rectangular prism, and so I follow that formula: length times width times height. And if you label them on your diagram, that's great. Again, you're recognizing that you're going to be multiplying all three of those dimensions together. But we could go ahead and label them. There's my length. Okay, the length of the box. There's my width of the box there, 2 meters. There's my height. Okay, it's also 2 meters. So I put those numbers in. 6 meters times by 2 meters times by 2 meters again. And my answer is going to be volume equals 6 times 2 is 12. 12 times 2 is 24 meters. 1, 2, 3. I have a cubed on the meters. Okay, because I've multiplied meters by itself 3 times. Okay. Make sure that always when you're reporting volume that your units are cubic units. Okay, so volume should always be in cubic or cubed units. Okay, we should always have that little 3 up on top. This is called a superscript, okay, and it's showing that that meters has been cubed. The homework for this lesson is to try the rest of your worksheet 2.1, well, part 2 that deals with volume. You can leave part 3 for now. Okay, but here is our homework 2.1, part 2, doing some examples with volume. They're all going to be in different units. You might deal with inches, feet, centimeters, meters, but you're just continuing with that same formula, okay, and calculating your volume in cubic units. So good luck. Thanks for joining me. See you next class.